Hey everybody, we're looking for ordered paired integers, positive integer solutions. A way of stating that is you say that xy is a member of n crossed with n. We're looking for ordered pair solutions. Now note, folks, that if this is a solution, that would imply, in fact, we can put if and only if. Let's say AB, where a and b are both natural numbers, is a solution. Because of the symmetry of this exponent, that would imply that BA. Okay, and that should be clear because this this expression is symmetric in the variables x and y. Nothing's going to change. If you have one solution, you can swap them around and it's still going to be the same solution in terms of equaling the constant on the right hand side. Okay, so let's keep that in mind. Now, we can rewrite this expression in this fashion, and it's useful to notice at the very beginning, in fact, you know, that both sides are going to have a base of 2 ultimately. All right, over here we have the 28th root of the square root of 2, okay? Well, that's the very same thing. The 28th root of 2 is equal to, and this is just converting from radical notation to rational exponent notation. This is the same thing as 2 to the 1/28th, right? Okay, again, most people prefer working with the rational exponents versus this radical notation. It's grown into a little bit of disfavor. But anyway, I still like this, and so we can rewrite this way, you see. Notice how the square root symbol went away, and you have the 1/28 appearing. You know, it was actually multiplied. And again, the rule there, of course, is the very well-known a to the m, the power. If you raise a power to a power, you multiply the exponents. Okay, so this is equal to amn. And I always like to explain that if you have n copies of m copies, you have mn copies. Easy to remember, doesn't require much proof, okay? So that's what happened here, folks. It's just that our n was 1/28. So that's how this happens. And we just, at this stage, folks, we look at this as just a glorified exponent, right? It's variable dependent, okay? But it is the exponent applied to the base 2. Notice over here, the right-hand side, you have 7. Now, any exponential function is 1-to-1, so we can equate these exponents. And when you equate this circled object with this circle object, this is the result, okay? So we know that x squared plus xy plus y squared is equal to 196. Now, we can quickly come up with a bound here for the x's and y's. I put 13. It's just because this is equal to 14 squared, right? Okay, so you can say they're all less than 13, right? There's no way 14 could be a solution, right? 14 squared would give you 196. And even if you allowed for 0, it still wouldn't work, right? Actually, I guess it would. If x were 0, y could be 14, right? But we are looking for positive integer solutions, okay? So that would be a solution if we allowed for integer solutions, or what I just said. But since we're only positive integers, we can say that x and y are both less than 13, right? Less than or equal to 13. And y'all, there's nothing sophisticated about what I did. I just went through some possibilities here. I tried x equals 2, y is equal to 13. I got 199. I tried x equals 3, y equals 12. I got 189. And so on. And I don't want to go through every bit of the discovery with you, but we got fairly close up in here, right? But now you can see we're starting to decrease a little bit. Not that that really means much, but y'all, again, I'm not going to write down every single one, but what I got finally as a solution is this 6 squared plus 6 times 10. The dot there to connote multiplication, plus 10 squared. And you can check out that that does add up. This is 100, this is 60, this is 36, so that adds up to 196. Okay. Now, I don't even know if it's the only one, but it is one. There, I kind of think I'm fairly sure it's the only one, but I've been wrong so many times. Sometimes there's surprises that you just don't see. But anyway, and I could systematically go through all the possibilities. I suppose I don't feel like doing that. But we did find one solution. So we get 610 as a solution. But remember, we said the symmetry, because of the symmetry of the expression of the exponent, we also get 10.6. And those are the only two positive integer solutions I found. Okay, and I guess it's fair to call them distinct solutions. Again, there may be others, I'm pretty sure, but again, I've been wrong so many times I don't care to put myself out, stick myself out in the open on that. But so the two solutions I get, folks, I'll just come right back up here, are 610 and 10.6. And I'm not even sure if there's there's got to be real valued solutions, maybe complex solutions right here. And if you allowed for negative integers, you could put plus or minus 6 and plus or minus 10. So I guess, you have 4 solutions that way? Yeah, you would have 4 solutions if you allowed for integer solutions. Maybe even more because of the 0 thing I talked about earlier. But anyway, that's it, folks. That's all I got. Okay, thanks for being.